Hello everybody, and welcome back to another video in my IB Math series. Today I'll be solving question 7 on the 2021 TZ1 IB exam. So let's get right into it. The question states, consider the quartic equation z to the power of 4 plus 4z to the power of 3 plus 8z to the power of 2 plus 80z plus 400 equals 0, where z is an element of the complex numbers. And two of the roots of this equation are a plus bi and b plus ai, where a and b are both integers. And the question wants us to find the possible values of a. So here, right away I can see that there's two pieces of information that they were given. So the first one is the quartic equation, which is this equation right here. And the second piece of information that we were given is a plus bi and b plus ar are two of the roots. And basically, there are two ways to solve this question. The first way is to use the sum of the roots and product of the roots, get two equations, and then solve for a and b. The second kind of more tedious way, I think, is to actually put these two roots, or put all of the roots into the original equation, kind of like try to expand it out, and then compare coefficients. That way you also get two equations and two variables. But I think that's a little bit of a more harder way, so we're going to go with the sum and product of roots method. So first things first, notice that using conjugate roots theorem, or I think that's what it's called, that the other two roots here are a minus bi and b minus ai. So let's write those down first. And this will be helpful to us later on. So now, we have to figure out what the sum of the roots are and what the product of the roots are. And to do that, we can use Vieta's formulas. So remember how the sum of any polynomial is going to be equal to negative an minus 1 over an. And the product is going to be equal to negative 1 to the power of n, a naught over an. And just remember that like a0, a1, a2, a3, a4, and so on, it's just referring to the coefficient in front of whichever term to the power of n. So for instance, an in this situation is going to be a4, because that's the degree of the polynomial right here. And a0 in this situation is going to be 400, since that is the constant term. And then if you count up, it kind of does make sense that the constant term is a0, because this is a0, a1, a2, a3, and a4. So same thing for the sum. An minus 1 in this case is going to be this term right here. Because n is 4, that's the highest power. If you go 1 down from that, that's 3. So let's go ahead and compute what the sum and product of these roots are. So sum here is going to be negative 4 over 1, because the coefficients here are 4 and 1. So this just simplifies down to -4. And now for the product of the roots, -1 to the power of n. So n in this case is 4, because that's the highest power. So this is equal to -1 to the power of 4 times a naught over an. A naught in this case is 400. So let's write that down. And an is just 1. So it's simplifying that a little bit. 1 to the -1 to the power of 4 is just going to be equal to 1. And then 400 is just 400. If you multiply anything by 1, it's just the number itself. So this just becomes 400. And now you might be thinking, what are we actually going to do with this information? So basically what we're going to do next is we're going to equate the sum and the product with the actual sum and the actual product of the roots. So remember how we found the other two roots up here? We're going to use those two roots again in order to find the sum of the roots and then the product of the roots. So let's do that. So the sum of the roots is going to be equal to a plus bi plus b plus ai plus a minus bi plus b minus ai. And if we look at this equation right here, we can see that these ai's cancel and these bi's cancel. So basically, all we're left with is 2a plus 2b. And now let's compute the product of the roots. So the product of the roots is going to be a plus bi times b plus ai times a minus bi times b minus ai. And this, if we rearrange it a little bit, we basically just get a difference of squares here and here, and a difference of squares here and here. So let's compute that. This is a squared minus b squared I squared, and then multiplied by b squared minus a squared I squared. Okay, so now we know that I squared is equal to -1. So we can kind of like replace every I squared with -1 as the next step. And this cleans up very, very nicely to just, oh, I lost a squared here. To just a squared plus b squared and then squared. Because these -1s will cancel out and become a plus, these -1s will become a plus as well. And basically, it just cleans up to a squared plus b squared, all squared. So now, we can actually go ahead and equate the sum of roots with the sum we calculated over here, and equate the product of the roots with the product that we have over here. So let's go and do that. Here we have systems of equations. So we can simplify one to just a plus b is equal to negative 2 by multiplying by 1/2 on both sides. So this is still equation 1. We can simplify equation 2 by square rooting on both sides. So we get a squared plus b squared is equal to 200. Or not 200, 20. And now, it seems the easiest way to solve this equation is to substitute 1 into 2. So 1 here is actually a is equal to negative 2 minus b. So let's substitute that into equation 2. So this would be equal to a squared plus, or not a squared, this would be equal to negative 2 minus b squared plus b squared is equal to 20. And then if we do some expanding, we get 4 plus 2 times negative 2 and times negative b plus b squared is equal to 20. This would be 4 plus 4b plus 2b squared is equal to 20. And then we can move the 20 to the other side. So it becomes negative 16 plus 4b plus 2b squared is equal to 0. Then this is b squared plus 2b minus 8 and finally we have b plus 4, b minus 2 is equal to 0. Oh, and actually I just realized something easier that we could have done. So basically we could have substituted in the value of b in terms of a, and then you would get to the same equation. But I chose to do b, which makes it a little bit harder. But that's okay, because if you look at it closely, this equation right here, you get the same thing by substituting in for a. So whatever values I get for b, I'm going to get the same values for a anyways. So here b is equal to negative 4 and a, and not a, 2. And just to make sure, I can substitute that into the easier equation. So a plus b equals negative 4, right? Sorry, a plus b equals negative 2. So solving for a, so if we do b equals negative 4 into here, then we'll get a is equal to 2. And if we do b is equal to 2 into here, then we'll get a is equal to negative 4. So basically, they have the same values because of the nature of the substitution. And I guess to make it more official, let's write a therefore statement. And there you have it. Question 7 of the 2021 TZ1 IB exam done. Hope you enjoyed the video, and as always, if you have any questions or comments, feel free to leave it in the comment section below. And I hope to see you in the next one.